Hi, my name is Andrew Allshorn. I'm the owner of At3D Squared Limited. I also work for 3D GBIRE as a technical consultant, and I'm also the Vice President of AMUG. So I've been in the industry for 30 years and I'm here to talk to you about Teton. So in 30 years of being in the industry, this is only the second time I've actually used a piece of software that has really made me sit up and think, hey, this is going to change the future of 3D printing. The first one was Magix, because it was so easy to use. And Magix, like I said, it helps you produce the files and get them all onto the 3D printer. What Teton does, it actually takes it a little step further. And at the moment it's specifically aimed at FDM, and it's aimed at producing a part and putting different properties in the different parts of the component. So it actually calculates and works out where the stresses are and where you need to have more fill, less fill, and gives you a part that's going to be more usable. So at the moment you can't do it on an STL file for an SLA machine, but for all the fibres you're fine. You can actually tell the software where you want the stresses to be added, and one of the nice features is it's done in a really simple way. So when you point the arrow to where you want the stress, you can actually say, I want it small amount of stress, medium amount of stress, and the way that they do it is they use icons like a baby, a teenager and an adult. So it gets people into this FDA analysis. A lot of the F1 teams and automotive use this all the time when they're developing products. So this is now helping the sort of home user, more industrial users are just getting into 3D printing, into a point where they can produce parts that are going to last longer, do the job properly, and yeah, it makes it a better end product. Students, engineering students, and basically the engineering students are going to learn that more about when you're building a part, it isn't just a part, it isn't just a plastic. You know, the same thing with these printers. I see people putting printed parts in positions in certain materials that they really shouldn't be doing it. And this helps them choose how to do it. And it also, if you put the material in, you put the specs, you put the where you want the stresses, and then if those can't be met by that material, the software will actually suggest a different material that will actually do what it wants it to. So that's a really good feature of it. You know, you're not just going to put a PLA part on and then this thing's going to say, actually, PLA is not going to be strong enough. You have to use carbon fill nylon or PETG. So that's the benefit of this, and I think the more people use it, the more they're going to learn. They'll use it less the more they use it, they'll use it less, because it's not just doing it for you. It's an education tool. You can see what it does. You can actually look at the slice files. So you can see the parameters that they've put inside, where it's put it, and I think that's a huge benefit. It's an educational tool as well for engineers going into structural engineering components. So, you know, the cost is really not prohibitive. It's at the cost where students can afford to get it, and it's one of those pieces of software that if a student leaves, goes into a company that's got a 3D printer and they don't have this software, it's not restrictive to the company that they're employing to buy it, which is really good. You know, you've got specialists in F1 teams that specialise in this FDA, and that's basically, this is getting them into it without having to buy all the expensive kit. Because of the situation I'm in, I only use it when I need to. I think people in the industry are going to use it more because it is so easy, and they're going to be designing things for their industry all the time, and they need to know, is it going to last? Is it going to be able to take the stresses, pressures? So it's really good. And the other thing is, it's just sliders, so they can actually go from and the other brilliant thing is they can actually print the part with all the different settings, and then they can test it. So if they're not sure whether adult pressures is too much and a baby's too little, they can build a 3 or 4, test it, and then they can test it properly until it breaks. So it's a really good way of doing it.
That's good. I like that.
And the design doesn't change.
Yeah.
The actual outside of the design doesn't change. The part stays the same. It's just the internals it's the next step. Really, it works with all the software. There are probably stress analysis pieces of software in some of the CAD packages, but this works straight off an STL file, which is really good. because I've never used it and done it on I use SolidWorks and I haven't ever used it on that. But yeah, I design for 3D printing, so then you think differently anyway. This helps you in this situation here. If you've got right angles, they become weak points. I'd actually design it with the radius in. But if you can't do that, this is a replica car part. If you can't do that, then what you can do is send this file off, and it basically will make the infill inside this particular section here a lot stiffer, so it's tougher. Yeah, so if you want to learn more about Teton, then you need to come and visit 3D GB IRE, and the guys here will be able to help you out.